Okay, so we carry on the second part of the previous video doing the 2020 Math Method Exam 2, Section B. Question 1, 11 marks. Let f be a quartic function, a times x plus 2 squared times x minus 2 squared. Part of the graph of f is shown below. So we have two turning points and one y-intercept 0, 4. Which is also a local maximum. First part, we want to show that a is a quarter. So by inspection, 0, 4 is on y equals f of x. Therefore, let's say 4 equals to f of 0. This will give you 4 equal to a times 0 plus 2 squared times 0 minus 2 squared. And left-hand side is 4. Right-hand side, this is 4. This is 4 again, so 16a. Therefore, a is 4 over 16, which is 1/4, as required. Express f of x in the form of f of x equals 1/4 x to the power of 4 plus bx squared plus c. Here I just used my CAS calculator and expanded in the standard form. This will be 1/4 x to the power of 4 minus 2x squared plus 4. Notice that if they want you to find the values of b and c, you need to state them. But here, you don't need to, because they haven't asked you for the values of b and c. Part of the graph of the derivative function f dash is shown below. So you want to find a rule for f dash in terms of x. 1 mark. Don't forget the rule is an equation, so you have to have f dash of x equal to something, okay? This will be x to the power of 3 minus 4x, or you can say f dash of x equal to 1/4 x to the power, hang on a second, now, x times x minus 2, x plus 2. Find the minimum value of the graph of f dash on the interval x within 0 to 2. So this is my domain restriction. Therefore, let gx, hang on a second, do we have g later on? Nope, good, no letter contradiction. So let's say g of x is f dash of x. G dash of x is 3x squared minus 4, equated to 0 for max or minimum. X will be plus or minus 2 root 3 on 3. Use your CAS calculator, but x goes from 0 to 2. Therefore, x can only be 2 root 3 on 3. So G minimum is f dash minimum of x, which is f dash 2 root 3 on 3. And it will be minus 16 root 3 on 9. A common misunderstanding will be substituting x value back into f instead of f dash. This time we want to find the minimum value of the derivative function, so you can't substitute that into your original function. Instead, you need to substitute that into this function here, okay? Right. H of x. So if you want to map the graph of f onto the graph of h, you need to compare them. For example, f of x is just a quarter x plus 2 squared, x minus 2 squared. If you apply a reflection in x-axis, you will get f1 of x equal to minus everything above. Then it will be extremely apparent to see translation 2 units upward. So you will see f2 of x, which is your new letter h of x, minus quarter x plus 2 squared, x minus 2 squared plus 2. You need to describe the two transformations in words. So you say a reflection about, or you say in the x-axis. Then a translation by 2 units upwards. Or you can say in the positive direction of y-axis. Okay? This is one possible sequence of 2 transformations. Alternatively, you can say from x, a quarter x plus 2 squared, x minus 2 squared, you can translate that function 2 units down first. Remember, this has to be minus 2 if you choose to do the translation first, because then you apply reflection in x-axis, which will give everything a negative sign, okay? Finally, it will be minus quarter x plus 2 squared, x minus 2 squared plus 2, compensated by the minus in the very front, okay? Right, 2 possible answers. State the values of x for which the graphs of f and h intersect. So you just say f of x equal to h of x. Solving that equation on CAS, you will get x equals plus or minus root 6 plus or minus root 2. X equals minus root 6 is here. X equals minus root 2 is here. This is x equals root 2, and this is x equals to root 6, okay? For the total area of the shaded regions, we know this area is identical to this area here. So you need a 2 in the front. Integral, we choose the positive values of x, root 2 to root 6. Which one is above? Upper is h, lower is f. Therefore, we can say, h of x minus f of x dx. With your calculator, if you have defined h and f on your calculator, you can easily type in this definite integral here and evaluate that, correct the 2 decimal places, which will be 2.72 units squared, okay? Finally, let D be the vertical distance between the graph of f and h. Find all values of x for which D is at most 2 units. Give your answers correct to 2 decimal places. If it's a vertical distance, I know D must be greater than or equal to 0 because it's a distance. Now, if you think of the graph itself, let me do a quick duplication, screenshot, copy. Maybe I should copy it down here. At most 2 units. So you could have something like, okay, within these 2 values or these 2 values, a distance is here, a distance is here, or the other way around, distance is here, a distance is here, okay? So there are 2 cases. Case 1, f of x minus h of x, when f is upper, h is lower, smaller than or equal to 2. But remember, it has to be greater than or equal to 0. This bit is your d. Another case, this will be h of x minus f of x greater than or equal to 0, smaller than or equal to 2. If you are doing specialist math, or if you are familiar with the term absolute value function, you could just say distance is absolute value f of x minus h of x, smaller than or equal to 2. Solving that equation on your CAS calculator will give you 2 sets of values. The first set is minus 2.61 smaller than or equal to x, smaller than or equal to minus 1.08. Or you can say 1.08 smaller than or equal to x, smaller than or equal to 2.61. Okay? Alternatively, you can express these 2 sets of x values as x is an element of minus 2.61 comma minus 1.08 close bracket union 1.08 comma 2.61 close bracket. Pretty easy. Let's move on to the second question. An area of parkland has river running through it, as shown below. The river is shown shaded. Okay, shaded region. The north bank of the river is modeled by the function f1 from 0 to 200. f1 of x is 20 cosine pi x over 100 plus 40. The second river is below f2 of x. The south bank of the river is given by this function. All distances are measured in meters. Okay, a swimmer always starts at point P, which has coordinate 50, 30. So we label that coordinate 50, 30. The swimmer swims north from point B. North means, okay, like that, vertically upwards. Find the distance meters that the swimmer needs to swim to get to the north bank of the river. Right, if we realize this distance is always the same between the 2 boundaries of the river, you can easily see this is 50, right? And this is 60. So the distance is just 60 minus 50, which is 10 meters, okay? The swimmer swims east from point P. Find the distance in meters that a swimmer needs to swim to get to the north bank of the river. If the swimmer swims east from point P, then it's a horizontal movement To get to the north bank, let's label this one as Q, R, S. So we want to find the coordinate of Q. But how could we do that? The blue line has the equation y equals 30. The intersection is actually the intersection between y equals f1 of x, y equals f1 of x, and y equals 30. So what I'm doing here is f1 of x equals to 30. So for x, let's say 0 smaller than x smaller than 200. X is 200 over 3, or x equals to 400 over 3. According to the diagram, I would say, Q and R. This is Q, this is R. So delta x will be xq minus xp. Don't use xr minus xq, okay? Because you are starting from p, ended up at q. This will be 200 over 3 minus 50, which gives you 50 over 3 meters. Of course, equation solving is very crucial here. And stating the correct answer is also important here. On another occasion, the swimmer swims the minimum distance from P to the north bank of the river. Find this minimum distance. Give your answer in meters, correct to 1 decimal place. Right, we need to refer to the diagram again. This time, I need to move the shortest distance from P. We know the shortest distance is actually the perpendicular distance. At this point, we have a tangent line, and the direction of movement is perpendicular to this tangent line. So why don't we just say, okay, this point has coordinate x, f1 of x. Let's say this point is t, okay? P is here, 50, 30. Another point t is on y equals what, f1 of x. So this is the distance. Distance equals to square root of x minus 50 squared plus f1 of x minus 30 bracket squared. This will do. For the minimum distance itself, we are actually finding a minimum value of that. On your CAS calculator, you should be able to do something like f minimum, d of x, comma x. You could specify the domain restriction 0 to 200, but it doesn't matter. It will give you a decimal approximation as the final answer. Anyway, you should write d dash of x equal to 0, 0 smaller than x smaller than 200. Solving that equation, you should get x equal to 54.47693 something. So the minimum distance is at this x value. You will get 8.475 blah blah blah, which is 8.5 meters. Okay. Alternatively, you could find the tangent line to the graph of f1 of x at this point, or you can say, okay, find a normal line Find the normal line at this point, then find the intersection between this normal line and f1 of x. With this coordinate, use the distance formula. Then you could also get 8.5 meters. But the x value will be slightly off. Calculate the surface area of the section of the river shown on the graph on page 16 square meters. So the area will be integrating from 0 to 200. Upper is f1 of x minus lower f2 of x. Don't forget your bracket, the x. This will give you 2,000 meters squared, okay? A horizontal line is drawn through point P. The section of the river that is south of the line is declared a no swimming zone. Find the area of the no swimming zone correct to the nearest square meter. So look at the diagram carefully. Right. Maybe let me just label the information. 200 over 3, x equals to 200 over 3, x equals to 400 over 3. Let me double check. Yes, obtained from part B. And this is my no swimming zone. In yellow. I think the idea is using this part to subtract the yellow part. Right. So let me have a look. Highlight everything and get a duplicate of this diagram. Alrighty. So area no swimming is the large area. I suppose this is 150. X equals to 150. Going from 50 to 150. The blue line is 30. Upper function minus the lower function f2 of x. Minus 200 over 3. 400 over 3. 30 minus f1 of x dx. Then you just use your CAS calculator to evaluate this expression, which is 2,000 divided by 3 pi. Pi minus 3 root 3 minus 2. Approximately it's equal to 837, yes, meter squared. Okay, easy. Scientists observed that the north bank of the river is changing over time. It is moving further north from its current position. The model, it's predicted new location using, the model is predicted new location using the function with rule y equals kf1 of x, where k is greater than or equal to 1. So it's actually dilating the function f1 of x. Find the values of a k for which the distance north across the river for all parts of the river is strictly less than 20 meters. Less than 20 meters. Okay, so let's say y equals k times f1 of x, which will be k times, let me have a look. 20 cosine pi x divided by 100 plus 40. So this will be 20k cosine pi x divided by 100 plus 40k. Then distance, which is d, let's say d north, dn, will be y minus f2 of x. f2 of x is just 20 cosine pi x over 100 plus 30. So you are subtracting that and that, taking 30 from 40k. Okay, your distance north of the river is 20k minus 20 cosine term pi x divided by 100 plus 40k minus 30. The reason why I'm writing the new function dn in this form is because I need to see this coefficient 20k minus 20 as a big A, which represents the amplitude. This one is my center line, okay? Use a capital letter C. So the range of dn, as long as A is greater than or equal to 0, because k is greater than or equal to 1. So 20k minus 20 is greater than or equal to 0. This will be given by center line minus amplitude, center line plus amplitude. So 40k minus 30 minus 20k minus 20 bracket. 40k minus 30 plus, hang on a second, I think I stop it up. Should be the other way around. 40k minus 30 minus 20k minus 20. And this is 40k minus 30 minus 20k minus 20. A plus minus 20k minus 20. This will be, okay, 20k minus 10. And this bit will be 40k minus 30 plus 20k minus 20. So this will be 60k minus 50. Right. And the distance should be greater than 0. 20k minus 10 greater than or equal to 0. 60k minus 50 is strictly less than 20. This will give me k greater than or equal to half. This will give me 60k smaller than 70. So k is smaller than 7 on 6, if I'm not mistaken. But k is already restricted as being greater than 1. So this one overrides k greater than or equal to half. Therefore, we combine these two together. 1 smaller than or equal to k, smaller than 7 on 6. Some people, I think, they included smaller than or equal to, which is not correct, because we want the distance strictly smaller than 20. So we can't have an equal sign here. Okay? This is our final answer. All right. Moving on to the next question, I suppose. Question 3. Number of minutes a delivery is made before or after. Okay, before less than 0, after greater than 0. If t smaller than or equal to a has a probability 0.6, find a to the nearest minute. Inverse norm distribution. T is a normal distribution. 0 and the standard deviation is 4, so variance is 4 squared. Probability t smaller than or equal to a is 0.6. On your CAS calculator, you should use inverse norm. Area left tail 0.6 and 0, 4. Mean and standard deviation. So this will be giving you the value of a. A is 1.013388. Correct to the nearest minute, I would say a is approximately 1 minute. Find the probability correct to 3 decimal places of the delivery being no later than 3 minutes. Okay, less than or equal to 3, capital T, after its scheduled delivery time. Given that it arrives after the scheduled delivery time, which means t greater than 0. Probability t smaller than or equal to 3. Given that t greater than 0. This will be the intersection between these two events, 0 smaller than t smaller than or equal to 3. Probability t greater than 0. This comes from, the numerator, norm CDF, 0 to 3. Mean value is 0, standard deviation is 4. This one is just 0.5 because it's just half of the total area. The top one and the bottom one eventually will give us 0.546745, blah, 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 which is approximately 0.547, okay? Right, conditional probability, not very hard at all. Using the model described on page 19, the transport company can make 46.48% of its deliveries over the interval -3 to 2. Okay. It has an improved delivery model with a mean of k and a standard deviation of 4 minutes. So the new probability density function, let's say fk of t, will be 1 over sigma square root of 2 pi times e to the power of -12 bracket, probably I need to zoom in a little bit, squared. This bit should be sigma. This bit should be t, because it's a function of t minus the mean value k. So what is my sigma here? The sigma is 4. So I will just write 4 here and 4 here. Then we want to find the values of k over the interval -4.5 to 0.5. The probability is the same. If you integrate your probability density function, you get your probability. Actually, it should be more accurate than 0.4648 because you can use norm CDF to calculate the actual value. In fact, this will give you 0.4648, 35188, blah, blah, blah. Then you can solve on your CAS calculator. Probably I need to demonstrate that because that is not very easy to complete. You need a solve button. You need an integral minus 4.5, 0.5. 1 over 4 times root 2 pi e to the power of minus 1 over 2 bracket fraction. Where's my t? T is here. Minus k. Do we have k? Here. Divided by 4 squared dt equated to norm CDF minus 3, 2, 0, 4, k. And if you press enter, it will return nothing. You have to press Control Enter. Here you go, 2 possible values of k, okay? So, one possible value correct to 1 decimal place, minus 2.5. Another one is minus 1.5. Just 1 decimal place, nothing more than that. Of course, you could use some symmetry properties to calculate the translation, but that will be another story. That is a possible way of calculating k values. Alternatively, you could try the following commands on your CAS calculator. Let's have a look. Solve button, norm CDF. We're going from minus 4.5 to 0.5 and 0, no. This is the new norm CDF with the new mean value k, but the same standard deviation 4. It equates to norm CDF bracket minus 3, 2, 0, 4, k. And again, you press Control Enter instead of Enter. It could give you k equals minus 1.5, but it will lose another solution. So be cautious with this method. The method above can give you both solutions at once. For Casio ClassPad users, you must be very careful because if you are using, for example, this command on your Casio ClassPad with numerical solve, after 2 or 3 minutes rotating on the screen, it will return nothing. So how could we use the second approach to calculate the other k value? Probably you want to see around t equals 0, it's symmetrical. So you can try, for example, minus 2 to 3 and see how it goes. Still minus 1.5. That's not very useful. What if you are reflecting the left-hand side expression? Let's say minus 0.5, 4.5. Doesn't work. So use your CAS calculator judiciously if you learned that trick, okay? Here is my suggested way to complete that 3-mark question to get both solutions. Right, part D. Arrival 0.5 probability that each delivery it makes will arrive on time or earlier. So this is your probability of success. 8 deliveries. Let's say x8 is a binomial distribution, n equals 8. Probability of on-time success, 0.85. Fewer than half. So half of 8 is 4. x8, the random variable, is smaller than 4. Probability of x8 smaller than 4 is actually the probability of 0 smaller than or equal to x8 smaller than or equal to 3. Grab your magic friend CAS calculator and press probability distribution by nom-CDF. Go from 0, now, number of trials 8, probability of success is 0.85. Go, start from 0, end at 3. The probability will be that number, and you need to round that to 3 decimal places. 0.00285 blah blah blah, approximately equal to 0.003. Okay. All right. Assuming that the rival company's claim is true, consider a day in which it makes n deliveries. So xn is a binomial distribution, n 0.85. Probability one or more delivery will not arrive. Okay, be very careful. You can't use 0.85 because now you are concentrating on the event not arriving on time. So it's the opposite, which means the probability of success in this case is 0.15. So xn is greater than or equal to 1, which is 1 minus probability of xn equal to 0. And this will give you 1 minus n choose 0 times 0.15 to the power of 0 times 0.85 to the power of n. And these two terms, let me use a highlighter. This is 1. Something to the power of 0 is 1 again. So the simplified version should be 1 minus 0.85 to the power of n. Or you could say 1 minus 17 divided by 25 to the power of n. Let me double check. No, not 25. It's actually 20. Okay, hence or otherwise, find the minimum value of n such that there is at least a 0.95 probability. Okay, so the above expression, 1 minus 0.85 to the power of n, is at least greater than or equal to 0.95. That means 0.85 to the power of n is smaller than or equal to 0.05. A fraction raised to the power, when the power is getting larger and larger, the whole exponential will be smaller and smaller. That means n must be greater than or equal to log 0.85 as the base. Argument is 0.05. This will give you n greater than or equal to 18.43 blah blah blah. Using the inequality to round it up, because it's greater than, n minimum is 19, okay? not rounding it down, rounding it up, okay? All right. An analyst from a government department believes that the rival transport company's claim is only true for deliveries made before 4 p.m. For deliveries made after 4 p.m., the analyst believes the company of a delivery arriving on time or earlier is X, where 0.3 smaller than or equal to X smaller than or equal to 0.7. After observing a large number of the rival transport company's deliveries, the analysis believes that the overall probability that a delivery arrives on time or earlier is actually 0.75. Let the probability that a delivery is made after 4 p.m. be Y. Okay, so start our observation. We need to categorize the deliveries according to the delivery time. Let's say this one is before 4 p.m. and this one is after 4 p.m. Before 4 p.m., the proportion or the probability. Okay, here you have Y. After 4 p.m., it's Y here. You know these two branches add up to 1, so this one is 1 minus Y. Now, within the case before 4 p.m., you have deliveries on time or late. After 4 p.m., you still have the deliveries on time or late. So let's have a look. For deliveries made after 4 p.m., on time has a probability X. Here. This is X. This is 1 minus X. So how about these two entries? Assuming that the analysis beliefs are true. A rival transport company claims that there is a 0.85 probability that each delivery it makes will arrive on time or earlier. Well, okay. The claim is only true for deliveries made before 4 p.m. Okay, so the claims is only true before 4 p.m. So this is true before 4 p.m. 0.85 is the probability arriving on time before 4 p.m. And the late probability is 0.15. We made the first but big move of this question. Now, what else can I use from the conditions? On time probability 0.75. That means this one multiplied with this one added up with this one times this one is 75%. Okay, so 1 minus Y times 0.85 plus Y times X equal to 0.75. If you use calculator to solve for Y, you should get Y equal to 2 over 17 minus 20x. Notice that you have your domain restriction 0.3 smaller than or equal to x smaller than or equal to 0.7. And if I'm not mistaken, the graph should roughly look like that. So this is x equal to 17 over 20. 17 over 20? No, the graph should look like this. Just give me one more second. Like that. And a 0.3, 0.7. Y, X. Minimum is here, maximum is here. Therefore, our Y maximum is Y at 0.7, which is 2/3, if I'm not mistaken. And also Y minimum is Y at 0.3, which is 2/11. Therefore, Y goes from 2/11 smaller than or equal to 2/3. Okay. That is a tough question. The toughest part is not calculating the answer. It's actually constructing the tree diagram and use the information organized in the tree diagram and construct that equation. Okay, joint probability. All right, question 4. We have 2 more questions to go. The graph of the function f of x equated to 2x e to the power of 1 minus x squared, where 0 smaller than or equal to x smaller than or equal to 3 is shown below. So we want to find the slope of the tangent at x equals to 1. Okay, before we make a start, I need to mention something. This one looks like an x-intercept, but it's actually not. Because if you substitute x equals 3, the value you got is not 0. It's actually 6e to the power of minus 8. This is a very, 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 very small value, but not 0. It's still a positive real number, okay? So now we find the slope of the tangent at this point. Of course, you need to define this function. Let's say f dash 1 is minus 2. Find the obtuse angle that the tangent to f at x equals to 1. Okay, so this is 2, this is 1. Roughly, the tangent line should be drawn like this. Should be drawn like this. Obtuse angle means, okay, we want this angle here. We all know the gradient is tangent theta equals to minus 2. Whereas in this case, we are solving for theta between 0 and pi. So theta is actually, what should I get? Let's say pi minus tangent inverse 2 multiplied by 180 degrees divided by pi, which is 1164.56 degrees. So theta equals to 117 degrees. Correct to the nearest degree. Find the slope of the tangent to f at the point x equals to p. Give your answer in terms of p. So f dash of p is 2e minus 4ep squared times e to the power of minus p squared. Okay. Of course, depending on which calculator you are using, you might have different answers. For example, you could say it's 1 minus 2p squared, e 1 minus p squared, which is also fine, okay? Find the value of p for which the tangent to f at x equals to 1 and the tangent to f at x equals to p are perpendicular to each other. So the gradient at x equals to 1 multiplied a gradient at x equals to p should be -1, which means f dash 1 multiplied by f dash p is -1. So -2 multiplied by your previous answer is equal to -1. Then we solve for P. Remember, P is a possible value of X. It should go from, it should be greater than 0, smaller than 3, okay? And notice at the endpoints, the function is not differentiable. So the p-value is actually 0.65525517. Therefore, p is approximately 0.655, okay? Hence, find the coordinates of the point where the tangent to the graph of f at x equals 1 and x equals to p intersect when they perpendicular. Give your answer correct to 2 decimal places. So coordinates. Using your CAS calculator, the tangent at x equals to 1 is y equals -2x plus 4. Tangent at x equals to p equal to 0.6552517. Y equals to half x. Definitely this one is half because you know the gradients are multiplied to get -1, which are negative reciprocal of each other. But you have to write the y-intercept in decimal form because this value here is not exact. 1991189 blah blah blah. In my CAS calculator operation, I included all possible digits, okay? Make sure your CAS is on float mode or float 12 mode, okay? To include all possible significant figures. Equation 1, equation 2. Solving equation 1 and 2 for x and y. Your x value is 0.803524, blah, blah, blah. Y is 2.392951. Therefore, point of intersection 0.80, 2.39. Don't forget to put your final answer in coordinate form, okay? In order to receive full credit. Right, 2 line segment connects the point 0f0 and 3f3 to a single point. Ooh. Q and f of n, where n is greater than 1, smaller than 3, as shown in the graph below. The first line segment, find the equation of the line segment in terms of n. So the gradient, this is O, MOQ is f of n minus 0 divided by n minus 0, which is 2e minus 1 minus n squared. Therefore, y OQ is 2e1 minus n squared times x plus nothing, okay? Straight line through the origin. The second line segment connects the point. Very ugly. So the gradient is f3 minus f of n divided by the difference in x values, 3 minus n. And y minus k is gradient times x minus h. You can choose this one, either q or let's say this one, OQP, okay? No, we used the letter P before. OQR, let's say R, okay? Either point Q or point R, whichever you like. In this case, y minus f of 3 is f of 3 minus f of n divided by 3 minus n times bracket x minus 3. Of course, on your CAS calculator, you have to define f and directly type in this equation. Then you will get an equation involving y, x, and n. But of course, the preferable form of equation for a straight line is y equals mx plus c. So this time, I solve for the letter y to obtain y qr is minus 2e n squared minus 8 times 3e n squared minus ne9 times x minus 3n e n squared minus e to the power of 9 bracket, then everything divided by n minus 3, okay? Anything equivalent to this should be correct. The most important part for this question, you can see the way they construct the question, 1, 2, 3. So they really want you to use the equation here and here. You notice there are equal areas. This area equated to that area. Therefore, the first bit, let me write. The first bit is 0 to n f of x minus y of OQ of x dx. Another bit is integral from n to 3 y qr of x minus f of x bracket dx. Essentially, if the area are equal to each other, you just equate this integral with that integral, okay? So instead of writing every long tedious expression, I will be writing the generic expressions, okay? So copy down everything here. Put an equal sign here, okay? And solve for n, which goes from 1 to 3 numerically. Should be ing form of the verb. Grammatically, we should be correct. Solving for n. Now, something I need to mention on our CAS calculator. For example, you have, let me create another problem. A new problem, you always start from f1 of x. So you should have 2x e to the power of 1 minus x squared. Okay, here comes your function defined as f1 to represent f. For example, you know y equals to fraction f1 of n times x divided by n. This is your first equation, right? Another equation will be y minus f1 of 3 equated to f1 n minus f1 of 3. Make sure the order is correct. It's n minus 3, not 3 minus n. So the order for the numerator and the denominator should be the same. Then multiplied with a bracket x minus. You have a f1 3 here. That means fx minus 3 here. Okay. Here comes your equation of the second line. To put it in y equals mx plus c form, you solve for that equation. Solve that equation for y, you should get that and expand it a bit. You should get something like that, okay? And you can collect this term and this term. So put it like this bracket, cross out the x, put the x outside the bracket, okay? Now, for the last part, I know the screen on your actual handheld is very small, but you can still copy everything bit by bit with extra care. The first integral is, let me have a look, 0 to n. Your function f, which is f1 of x, minus in the integral, I only need the right-hand side, the expression. So copy, paste, dx, equated to integral from n to 3. And whichever equivalent form you can use. In fact, for simplicity, I'll just use this factorized form. It's the line, take away the curve, f1 of x dx, comma x, comma n, because you are looking for n instead of x. Of course, this equation will be very hard to solve analytically, so we are using Control Enter. We have 3 possible values, but remember, your 3 values must be within 1 to 3. So you eliminate this one, you also eliminate this one. The only possible value is 1.088, okay? This value here. You don't need to include everything. You just need to specifically mention n goes from 1 to 3, okay? All right. Finally, here comes the ice on top of the cake. Question 5. Especially the last 2 marks, very hard to get. So, g of a is the tangent to the graph of f at x equals a, where a is any possible real number. F of x is that expression here. B of 0 is the x-intercept of the tangent line. We want to show B is that expression of A. Okay. Here I will highlight my use of CAS calculator in the last question. Create a new problem. X to the power of 3 minus x. And again, we are using f1 of x to represent f. Add a calculator. Type in y equals menu for 9, calculus, tangent line, and f1 of x, comma, at x equals a. So this is my equation of tangent. Now, if I want to get my x-intercept, which is x equals b, we need to make y 0. So we need to substitute y equals 0 and x equals to b. So this is my equation involving a and b. The next thing is solving for b. Here comes your answer. But how could we just write 3 key steps to show the to show that for the 3-mark question? That's in the interest of nobody, in the favor of nobody. So for any show that question, probably you'd better show all possible steps manually, but you can check your answer using your CAS calculator. Firstly, I need to find the derivative. Then the gradient of tangent at x equals a will be 3a squared minus 1. Okay? Now, equation of tangent. Y minus f of a will be mt times x minus a. So y minus what? A to the power of 3 minus a is 3a squared minus 1 times x minus a. Subbing x equals b, y is 0. b minus a cubed minus a bracket is equal to 3a squared minus 1 times b minus a. And hang on a second, I think I fluffed around this a bit. So this y is 0. So you should have a minus a cubed equated to 3a squared minus 1 times b minus 3a cubed plus a. Okay? These two a's can be cancelled out. And you should have 3a cubed minus a cubed equal to 3a squared minus 1 times b. Therefore, 2a cubed equal to 3a squared minus 1 times b. Hence, b is 2a cubed over 3a squared minus 1. Okay? Easy peasy, lemon squeezy. This is one possible way of attempting this show that question with sufficient amount of working. Alternatively, you could say, all right, instead of relying on pure brute force algebra, we can visualize the problem by drawing an appropriate diagram. It is not very hard for us to see the graph of f looks like that. So, for example, this point is a comma f, f of a. If we draw a tangent like that, we immediately realize this is b comma 0, isn't it? Let's say at this point, gradient of tangent is f dash of a, which is 3a squared minus 1, isn't it? Also, gradient of these 2 points, is given by fa minus 0, a minus b. Then we can equate the gradients. F of a minus nothing, a minus b equal to 3a squared minus 1. And then a to the power of 3 minus a divided by a minus b is 3a squared minus 1. A cubed minus a is 3a squared minus 1 times a minus b. And the rest calculation follows in these steps, okay? This is approach 2. And this is approach 1. Some interesting fact. Approach 2 is much favored by many elder, experienced teachers who had taught math method for 20 or 30 something years, which must be appreciated. But I've only been teaching math method and specialist math for almost 10 years. So my approach is relatively new and more technology based. Therefore, approach 1 will be, more technology based, using your CAS calculator and then do the necessary by hand calculation. Whereas approach 2 is a very clever approach, a very famous approach called equating the gradients, very important in math method. Right, state the values of a for which b does not exist. So the denominator will vanish. Therefore, b will diminish. How could I spell it correctly? Diminish when a is root 3 on 3 or minus root 3 on 3, if I'm not mistaken, okay? State the nature of the graph of GA when b does not exist. Okay, I've got a simple diagram here. 0, minus 1, 1. It is not very hard for us to see when a is minus root 3 on 3 or root 3 on 3. They correspond to 2 stationary points. With these 2 stationary points, the tangent at these 2 points will be very special. 0 gradient, what is that called? Horizontal tangent lines. Actually, nature. Normally, we use nature to describe the stationary points. So let's just say corresponding to the local max or local mean. But I think you need to mention it's horizontal tangent lines, okay? State all values of a for which b is 1.1. Give your answers correct to 4 decimal places. So this is just a solve button question. And let's see. Do we have any restrictions yet? No. 2a cubed over 3a squared minus 1. This is b equated to 1.1. Solving for a, you should get the following values: minus 0.5, 505, or A is just 0.808. 4 decimal places. Oh, be very careful. Need to include, actually I should include all digits. 505, 173,15119. A is 0.808, 4077, 953, blah, blah, blah. A is 1.34676,535, blah, blah, blah. Okay, 3 values. Then you need to round them to 4 decimal places. Minus 0.5052. 0.8084, 1.3468. 4 decimal places. The graph of f has an x-intercept at 1, 0. State the values of a for which b is greater than or equal to 1 and smaller than 1.1. Give your answers correct to 3 decimal places. Well, thanks to Warmth Math Academy, he mentioned the inability of Casio ClassPad to produce both set of values. For TI-Nspire users, you can just rely on your solve button. 1 smaller than or equal to 2a cubed, 3a squared minus 1, smaller than 1.1, comma a. And you should hit Control Enter. Here is the full set of values. I just copy paste. Be careful with any transcription error, okay? I'm being naughty and lazy this time. Okay. Now do the right thing. Actually, close bracket, union. Something like that, or you could just write the inequality notation. That doesn't matter. Right. Okay. In terms of the graphical approach, for Casio ClassPad users, you have to sketch the graph of, for example, paste it here, change all a to x. Okay, here comes your nice looking graph, a rational function, which you normally see often in specialist math, but doesn't matter. You've got your TI-Nspire or Casio ClassPad. Put a 1 here. And another 1.1. Right, looking at the intersections, analyze graph intersection, this one and this one. One possible intersection, this one and this one. Another intersection, one comma 1, and also intersection here. another intersection. So don't worry too much about the 1.1 because when you're writing from this value, from 0.8084 to 1.34677, a equals to 1 is already included within this interval. All you need to worry about is the left interval, okay? Right. Find the values of A for which the graph of GA and GB where B exists are parallel and where B is not equal to A. Parallel tangent equating the gradients again. So we go back to, actually we can create another, let's say, calculator page. Ooh. Let's say manual algebra, solve system of equations, solving for A and B probably, A comma B. You have two gradients, 3A squared minus 1 equal to 3B squared minus 1. The other equation relating A and B is B equal to 2A cubed, 3A squared minus 1, solving for AB. So you have two equations, two variables. Sufficient condition, just enough to solve for A and B. But one little extra but handy condition is A not equal to B, okay? With this, the CAS will give you all possible solutions satisfying the condition A not equal to B. If you are not including the last few lines, you will get, whoa, that's too much. Then you have to eliminate any solutions not feasible. So I would say the first line is more useful. All right, but how could we phrase our working out? F dash A is F dash B, whereas B is 2A cubed over 3A squared minus 1. Solving simultaneously for A and B, where A is not equal to B. A is, B is, A is, B is, okay? Now, minus root 5 on 5, root 5 on 5. Root 5 on 5 minus root 5 on 5. Done. Ooh, last 3 marks. Now we have a new function p of x for the rest of this question. Show that p minus x is minus px. That means it's an odd function. Right. Left-hand side is p equals p minus x, which is minus x to the power of 3 plus w times minus x, which is minus x cubed minus wx. And this will be taking out minus 1, x to the power of 3 plus wx. And this is just negative p of x, which is right-hand side, shown. Alternatively, I'm not sure whether the second method I'm about to show is reliable or not, but you can have a try if you encounter similar question. P of x is x to the power of 3 plus wx. W is any real number. Since y1 equals x to the power of 3 is an odd function. Y2 equals wx is also an odd function. The sum of two odd function is also an odd function. Therefore, P of x equals to y1 plus y2 is odd. And it is true that P minus x equal to minus P of x. Comparatively speaking, if you use the second approach, I would say you need to write more words and rigorous explanations or reasoning. Preferably, just stick with left-hand side equals to right-hand side, okay? Right. A property of the graph of P is that two distinct parallel tangents will always occur at t, P of t, and minus t, P of minus t for all non-zero value of t. Find all values of W such that a tangent to the graph of P at this point for some t greater than 0 will have an x-intercept at minus t0. So, add another problem. Define P of x equal to x to the power of 3 plus W times x. Remember, you have to have W times x, not Wx. Otherwise, the CAS calculator will recognize Wx as one letter. All right, so y equals to tangent line P of x, x, t. Here comes your equation of tangent in terms of y, t, and x and w. Now they tell you you have something. What? It is the x-intercept, x equals minus t, and y equals 0. Substitute the x and y's in the equation, you get a reduced equation in terms of t and w only. Then, from that equation, you solve for w. All right, of course, t is non-zero, so you have to choose w equals to minus 5t squared. Okay, now, let me make a screenshot of that one. Okie dokie, paste. Finally, with the WT function, you just sketch a graph. So this is an inverted parabola, concaving down. The maximum value is 0, 0. With the given domain t greater than 0, you can see, all right, W is all negative real numbers, or you just say W is negative infinity to 0, okay? All values of W. With CAS calculator, your good friend, very easy. The very last question, when I first saw the paper, I got stuck with part H. That is why I'm saying this one is the ice on top of the cake. But let's see. M and N, these two are dilation factors. Possibly if M and N are negative numbers, it could also be reflection factors, okay? H and K, these are translations, horizontal translation H. K is a vertical translation K. So we want to state any restrictions on the values of M, N, H, and K, given that the image of P under the transformation T has always have the property that parallel tangents occur at x equals minus t and x equals t for all t not equal to 0. What I'm doing here, graph approach. I would draw a couple of graphs. I believe other teachers will also adopt this approach. Discussing a number of family of graphs. Let's see. Okay, so let's consider P equals x to the power of 3 minus x as a special case. Doesn't matter which value of w we choose as long as it's a real number. For example, let's choose this one as minus t. The symmetrical point will be x equals to t. Definitely, you will have a parallel tangent here and here, okay? If you somehow dilate, for example, let's say if m is greater than 0, you're actually widening the function. Okay, now at this point, x equals minus t, the tangent line looks like that. At this point, the tangent line looks like that. Okay, they're still parallel to each other. So does the reflection upon P of x, whether it be about the x-axis or y-axis. That means M and N are still non-zero real numbers. Okay, so let's think of the translations only. If it's translated upwards, doesn't matter, because the translating shift upwards or downwards after differentiation, it will be 0. So the translation factor k will have no effect on the gradient, which guarantees the gradient at the symmetrical points to be the same. Okay? It's just shifting upwards and downwards, shifting the tangent lines upwards or downwards, but they are still parallel to each other. So k can be any real value. However, if you are trying to shift the function left or right, it's another story, because once you shifted the function left or right by whatever number, whatever translation shift, you will see the symmetrical point will no longer produce the parallel tangents. Here is x equals t. Here is x equals minus t. So if it's not shifted, still symmetrical around x equals 0, parallel tangents. Good. But when you shifted it to the left, see at this point, the tangent line looks roughly like that. However, look at this line and this line. See? The two tangents crossing each other, not parallel to each other anymore. Therefore, you can't take other values of h other than 0. So h must be 0. Okay? What's interesting in the wording of the question, of this question itself, is that they state any restrictions rather than the restrictions or all restrictions. That's one interesting, very interesting aspect of the phrasing. Okay, but anyway, we've tried our best to analyze all possible values for m, n, k, and h. Okay. Hopefully you guys could find this video helpful in some way, at least, in particular for those who will be attending math method exams in 2021 onwards. Right, it's time to finish this video. It's quite late, and now it's the last day of 2020. Here, I would like to extend my best wishes to all of you who are watching my video or will be watching my video. Thanks for watching, and Happy New Year. Have a nice 2021. See you next time. Bye-bye.